All right, so what we're looking at, I want to do a handful of these. First one being this one here. Okay. All right, so here's the idea with this one. They want you to find the area of the parallelogram, which is going to be, hopefully we all realize this, it's the solid lines, right? The shape made by the solid lines. So they want to find the area of that thing, okay? And if I find the area of that thing using, let's use just this information, okay? If I was using just that information, how do I find the area of that parallelogram? 12 times 8, okay? So 12 times 8 gives me 96. Okay with everybody? Okay. The next thing they do, now the picture is kind of hard to look at, and they do this on purpose. But the next thing that we want to do is ultimately look at this picture, see if I can rotate this. I should be able to. Yeah. By kind of looking at it that way. Does that make sense? Because now if I look at the area, when I do that, does the area change? No, I just rotated it. But now we're going to be looking at not that, using that number. Okay, now when I rotate it here, obviously a 10 got screwed up. Oh, 10. And I'm not going to use that number, right? They want me to find this value here, which is h. Okay. How do I find the value h? What is the formula for finding the area of a parallelogram? Base times height. We're looking for that h, right? Do I know the base that h is drawn to? What is it? 10, right? So base is 10. Now, a is a variable. And I think we need to understand that. When we have these formulas, the capital A is a variable. It's unknown until we start filling in B and H, right? In this situation, though, it should be known. What is capital A? It's 96. That's why we had to do this blue area first. So that's 96. So then, how do I solve for H? Divide by 10. Okay? And that will, if that's 9.6, then 9.6 times 10 still gives me the same 96 units squared for an area. Okay? Now, what I think is hard about that, what people struggle with, is obviously the static picture like that. Okay? You got to either redraw it or kind of put it in your mind's eye and rotate it or rotate your head or whatever so you can see that h is indeed an altitude, and the 10 is the base that it's being drawn to. Okay? So I think that's important for us to see. You'll definitely see that on a quiz in this chapter. I see people kind of wasting time on this one. I see people taking this triangle here, find its area, and then find the area of that one, which is fine, and then they add those together, right? But the area of a triangle says it doesn't have to be a right triangle. You just need a base and an altitude. What would you use? If I'm looking at the overall blue triangle here, what would be the altitude? Or the only altitude that's being shown? It'd be 4. That'd be h, right? What would be the base that that's being drawn to? 9. So area equals 1/2, 4 times 9. 2 times 9 is 18, right? It's going to be 18 square meters. Which dimension there do you not use? 45.5. Okay. What about looking at that one? Okay? What is the altitude? The altitude is 6. Okay? What is the base that altitude is being drawn to? Which 3? Yes, this one here, right? Okay? It's the base of the triangle that you're finding the area of. Okay? And the altitude does not have to intersect it. So that would be 3. So now 1/2 times 6 is 3. 3 times the 3 that's in the middle is 9, right? Okay? Oops. All right. The only thing I've been seeing on this one that people struggling with is that they mess around with what parallelogram they're asking you to look at. I've worked with some people and they've been wanting that parallelogram. With some other people, they're wanting that parallelogram. With others, they're wanting that one. Okay? Just make sure that you read which parallelogram you're interested in. But don't they all, no matter which one they want, don't they all have that height right there? Okay? And you can find that by taking, so that's at 5, J's at 5, C's at 1, so isn't that height 4? Okay? And then you can do the same thing for finding whatever base that they ask you for. Just subtract the x values that are attached to those respective bases, either AB, AD, or BD, whichever one they want you for in that question for you. We do okay with this one? Graphing lines? Okay. The end of course exam does ask you to do some graphing. Okay, graphing lines. How about this one? There's a few different ways you can break this one up. And as you're breaking these pictures up, it's important to kind of think about kind of how they're guaranteed to provide you certain measurements. Now, how do I make that bigger? I guess I can zoom in on it. All right. For instance, if I just want to do this real quick. If I were to take the line from that point there to that point there, do you see how, if I were to zoom in on this triangle right here, do you see how it doesn't really make a triangle here? Okay? And I did see people trying to do that, and you don't end up with the right area if you do that. Okay? The best way of coming up with this area is to do something like that. Okay? Where if I do that, I extend that segment, this becomes a right angle, correct? Okay? So this is a rectangle that is 120 by 60, correct? Okay, so I'll let you multiply that out. Should give me, so 12 times 6 is what, 72? Okay, and then I've got a factor of 10 here and a factor of 10 there, so 7,200 should be the area of that rectangle. Now I've got to find the area of the triangle. And this is where it gets kind of problematic. If this is 60, what is that there? 180. Okay? Because the whole distance is 240, right? If this is 120, what is this distance right here? 80. Because you got to take that 120, remove that 40, right? So now the area of that triangle is 1/2 your base. Maybe you let the base be 80 and the altitude be 180. So now 1/2 of 80 is 40, right? Okay. So factor of 10, so I know I'm going to have 2 zeros on the end of this thing. 4 times 18. 2 times 18 is 36, so 4 times 18 is 72. So I get 7,200 for the triangle. I get 7,200 for the rectangle. So that's 14400. So 1,000. So what is that? 14,400. Okay, would be the total area of that figure. okay? Chunk it up to where it makes sense to you to be able to find all the dimensions you need for the formulas that you need, okay? Some people have been doing this, kind of breaking it up into two rectangles, and you can find the dimensions of this rectangle, you can find the dimensions of that rectangle, and you can still find the dimensions of this triangle, so that will work. I think it's more work, but it is still nonetheless going to give you that 14,400 number. Some people try that. Okay, well, that kind of puts me in the same predicament as before. Is that I don't necessarily know if this is a special type of triangle. I don't know if it's a right triangle or anything like that, right? So finding the altitude of that thing would be hard. Okay, this is a trapezoid now. Find the area of trapezoid. Maybe you don't know that formula yet, or maybe you did this and said, okay, I can find the area of this thing here. I can find the area of that triangle. That wouldn't be too bad. But again, finding the area of this triangle, because I don't know whether it's a right triangle or not, would be difficult. Okay? So we have to be able to figure out the convenient ways of splicing these irregular figures up so that we get easily obtainable areas. We kind of ended class yesterday. I think the bell rang when we were talking about this, or a question like this, an example like this. And I like these. And you're going to see more and more of these types of problems throughout pretty much all of the area concepts and surface area and volume concepts that we work with for the rest of the year, for the mere fact that it forces you to know your previous information. Okay, so if I look at this one here, what kind of triangle do you have here? You have a right triangle, right? Okay. We need that distance there to find the area of that triangle. It's 1/2 BH. Okay, and depending on what you want B or H to be, that's either B or H, and then this would be the other one, right? Okay. How can I find that dotted line distance right there? Pythagorean theorem. Okay. Now this is a Pythagorean triple here. Okay, but I don't know how many of us realize that when I take 13 squared and remove from it 25, which is 5 squared, that is equal to, I'm going to call it B squared. So that's 144 is equal to B squared, right? So B would be 12. So 12, 5, and 13 are Pythagorean triples, much like 3, 4, and 5 are, right? Okay. So a lot of times maybe if you've remembered that or you've seen that enough, that you could go straight to that 12 by that, I don't want to say common knowledge, but somewhat common knowledge. So that's 12. Okay. That means that this thing here is a rectangle, right? So how do I find that area? Length times width, base times height, 10 times 12, right? So 120. And now finding the area of the triangle, it would be the 1/2. Base is 12. Height is 5. What number does that 1/2 work with best, 12 or 5? 12. So I'm going to do that order of operations first. So it gives me 6. And now I get 30, right? Okay. So 30 is the area of the triangle. 120 is the area of the rectangle. 150 is the total, right? Okay. Questions on that? You're going to see over and over and over again questions that ask you to use the Pythagorean theorem to find H or B or something like that. They're going to ask you to use SOHCAHTOA to find H or B. They're going to ask you to find H or B using special right triangles. That stuff is going to be in the forefront of a lot of our problems. Happens again in this last question. Actually, let's do this one first. What do you know about the diagonals of a rhombus? Say it again. Careful. They're only congruent in a special rhombus. They're only congruent in a square. They're perpendicular. So they're perpendicular, and they also do what to one another? They bisect each other. Good. Okay? So all those relationships from chapter 5 and 6, I think that's chapter 6, are necessary to be able to address what to do here. Okay? And to find the values that are essential for our formula. Now, I haven't introduced the rhombus formula to you. That's going to be, it was initially meant for today, but we kind of ran out of time last period, so we'll put that off to tomorrow. But there is a formula. It's this, 1/2 D1 D2. But we're not going to use that here. This question is out of 10.1. It's not meant for us to use that formula. It's meant for us to find the area of one triangle and then do what with that one triangle? What do you know about all four of these triangles? They're congruent, right? Biside, angle, side, those, because of you saying that the diagonals bisect each other, we got right angles here. We get side, angle, side for these four triangles. So they are congruent triangles. So if that's 5 and that's 13, here's the common knowledge that we've seen this enough in the last question. What was the number that went with 5 and 13 in Pythagorean triple? 12. Okay. 5 squared is 25. 12 squared is 144. Add those together, you get 169, which is 13 squared. Okay. So now, area of that triangle would be 1/2 B times H. So 1/2 B, maybe it's 5. H, maybe 12. So give me 30 again. But that's just for one triangle, right? And you multiply that by 4, and I get 120 then for the area of that rhombus. The formula ultimately, guys, the 1/2 D1 D2 that I'll show you tomorrow, kind of takes care of that multiplying by 4 inside the formula, so you don't have to worry about it at the end. Okay, but that's the approach for that question. And then this is one of my favorite questions of this assignment. That was a hint. And after today, we're going to have a I want to do it that way. After today, we're going to have a formula that actually addresses this a little bit quicker. Okay? But with trapezoids, without a formula, we always want to draw an altitude so that it's kind of right there at that vertex so that you construct a triangle and a rectangle. Is that all right? And when I do that, what kind of triangle do I have over here? A right triangle, and it's got it's a 30, 60, 90. So 4 is what side in a 30, 60, 90? Careful. It's 2n. Okay? Your hypotenuse is always 2n. So what is n then? If I solve that. N is 2. And what side does that go across? Goes across the 30, right? Okay, so that is the 2. What does this become? 2 radical 3. Okay, so if we're iffy, which I think maybe some of us are, on that setup for the special right triangles, please go back to chapter 7 and revisit that information. Chapter 8, revisit that information. Okay. But now that we've done that, do we have the area of this rectangle as being B times H? What do you want B to be? I'm looking at this rectangle. What would be B? 13? What would be H? 2. Does that matter? Which one was B, which one was H? No, because multiplication is commutative, so it doesn't matter. But that gives me 26. Now I come over here, area is 1/2 B times H. So 1/2, what do you want B to be there? 2? Did you say 2? Okay, 2. And then the other one's got to be 2 radical 3, right? Does it matter which one's B, which one's H? No, because they're right triangle and they're both altitudes, so either one can be H. then that makes the other one the base. Okay? And because of the commutative property of multiplication, again, they shouldn't matter. B times A, same thing as A times B. Order of operations, I would just do that first. What's 1/2 times 2? 1. So let's just kind of wipe each other away, right, in terms of multiplication. So now I have 1 times 2 radical 3, which is just 2 radical 3. So if I want the area of this entire trapezoid, it's 2 radical 3 plus the 26 of the rectangle, right? Now I know that the question asks you to write it as a decimal or something like that. But I've created quizzes and test questions that I want to ask for 26 plus 2 radical 3, okay, for multiple reasons. If I don't ask it for that way, you don't experience the process of going through the algebra, okay, so you don't get better at the algebra. You don't get better at realizing rational numbers work well with rational numbers, irrational numbers don't work well with rational numbers, and that kind of thing, okay? So there's some mathematics that is not necessarily just purely geometry that we get better at when I ask you to leave it as 26 plus 2 radical 3, okay? And that's going to, if we continue to get better at that stuff, that's going to pay huge dividends for you next year, okay? Next year, you don't know who your teacher is going to be, right? You might have a teacher that assumes you know all that stuff and never teaches it to you, okay, or revisits it, okay? I mean, if you had Miss Coles next year, you know she's going to revisit that a little bit, right? Okay, but you might have somebody completely new that does not do that. So hopefully we pick up on some of this stuff. All right, questions on that? Is that assignment? I know some people have questions on that, the parallelograms and trapezoid pictures and what to do because we're missing some parts. Okay, when we're missing parts, when we're missing components for our formulas, you always want to kind of think about triangles because we've worked so much with triangles. How can you generate a value using special right triangles, Pythagorean theorem, SOHCAHTOA, that kind of stuff? And that's probably, I'd say 95% of the time going to get you unstuck inside your problems. Okay. I want to transition today